We are going to begin our review for the second type of FRQ that you will see on the AP exam. The second type is calculus basics. Now, the basics can cover a wide range of things, and when I say basics, it doesn't mean the simple things, it doesn't mean the easy things, it just means that there's not necessarily an application here. It's going to be involving taking derivatives, integrals, using different methods, higher level methods. Lots of different avenues that we would consider calculus basics. This can cover a wide range of things here. But to do that, we are going to cover these 5 problems from prior free response questions, prior years. The first one is our introduction, and we're going to cover number 5 of the 2014 exam. Because it's the latter part of the exam, this is a non-calculator problem. So with that, let's go ahead and get started. What we have here is a table, not a traditional table, but a table of values for f, f prime, g, and g prime. And it gives us values for specific points, and it gives us signs for specific intervals. The prompt tells us the twice differentiable function f and g are defined for all real x values. Values of f, f prime, g, and g prime for various values of x are given in the table above. Part A says find the x coordinates for each relative minimum of f on the interval -2 to 3, and that's closed interval. So just to kind of wrap my head around what's going on here, I'm going to notice that I am looking for a relative minimum of f, and thinking through how to find a relative minimum, that implies that I need to take the derivative and find all the critical points and look for when the derivative is changing signs. Somehow, some way. We'll justify it later. But essentially, we're looking for when the derivative changes signs. Well, before we do that, we have to find all the critical points. Now remember, critical points are when f prime equals 0, when f prime does not exist, and at endpoints. Well, we can see here f prime always exists. It's -5 here, negative in this interval, 0, negative in this interval, 0, positive in this interval, and 1/2. So it always exists. The next step would be setting f prime equal to 0. We see that f prime is equal to 0 at -1 and 1. And then our other critical points are endpoints. And because this is a closed interval, the endpoints count at -2 and 3. So I'm going to say consider when x equals -2, -1, 1, and 3. And for my own sanity, for my own understanding, I'm going to go ahead and create a number line for this, and I'm going to have the number line for f prime, and I'm going to label these values. At -2 we had an endpoint, at -1 f prime was 0, at 1 f prime was 0, and at 3 we had another endpoint. Now we can see up in this chart that f prime is negative for the interval from -2 to 1. It's negative from -1 to 1 and positive from 1 to 3, so I can put those signs in there. This number line is not necessary. In fact, it's something that the AP readers have been instructed not to even consider or look at when they're grading. I just like having it there as a comfort item, I guess you could say. But now I can justify a lot easier. I can see where my minimums are. We can see when x equals -2, just to the right of that, f is negative, which means f prime is negative, which means that f is decreasing. That would imply that there's a relative maximum at this endpoint. Here we have no extrema because the derivative doesn't change signs. Here we have a relative extrema because f prime is changing from negative to positive. We're going to have a relative minimum. And then at x equals 3, we can see that f prime is positive right before it, which means f is increasing to the endpoint, which would imply you have another relative maximum there. So really we only have one relative minimum, and that is when x equals 1. And the justification would be since f prime changes signs from negative to positive at that point. Point values for this, you're going to get 1 point for your answer and your justification. So if you have the correct answer but no justification, you don't get this point. The number line does not count as justification. You have to put it into words. Okay, for part B, it says explain why there must be a C value over the interval -1 is less than c is less than 1, such that f double prime of c equals 0. So immediately when I see explain why there must be a c value, I'm thinking that I have one of my theorems that I have to use. Intermediate value theorem, mean value theorem, extreme value theorem. Well, looking at what I want to know when f double prime equals 0. Well, I don't have anything about f double prime in this table here. I do have something about f prime though. And so we can think, okay, how do I go from f prime to f double prime? That's taking the derivative of f prime. And so this is going to be a mean value theorem. And so we can say that since it says here, it says that f is twice differentiable, that would imply that f prime is differentiable. Okay, so since f is twice differentiable, f prime is differentiable. And that would also imply, since f prime is differentiable, f prime is continuous. And then as a result, we can say the mean value theorem applies. And since the mean value theorem applies, now think of what the mean value theorem says. It says the average slope over an interval is going to be equal to the derivative at some point within that interval. And so I'm going to go ahead and find my average slope from -1 to 1. My average slope from -1 to 1 of f prime is going to be f of 1 minus f of -1 over 1 minus -1. And so we can say, simplifying that, that's going to turn out to be 0. So we could say that f double prime of c does equal 0 for some c value in the interval -1 to 1, since f prime of 1 minus f prime of -1 over 1 minus -1 is 0. And again, that's by the mean value theorem. And so we can say we get, as far as points go, you get 1 point for showing the difference quotient. That's meaning the slope. So 1 point for showing that the slope between -1 and 1 is 0. And then 1 point for your justification. But your justification must include the use of the mean value theorem. And for the mean value theorem to work, you have to explain why it works. So you have to explain that f prime is differentiable and that f prime is continuous. All right, so that is for part B. Looking at part C, it says the function h is defined by h of x equals natural log of f of x. Find h prime of 3. So in order to do this, we need to take the derivative of h. So the derivative of h prime, is going to be equal to 1 over f of x times f prime of x, because the derivative of natural log is 1 over whatever the argument is, so it's 1 over f of x. And then we have to apply the chain rule because we have a function inside the natural log. We have to take the derivative of that. So that'd be times the derivative of f, or we'd say f prime. So we need to figure out what h prime of 3 is. So we're just going to go ahead and plug 3 into the x value. And then from here, we're just going to use our table to evaluate these things. So you got 1 over f of 3 times f prime of 3. Well, f of 3 up here says, f says 7 when x equals 3. And then f prime of 3 is going to be 1/2. So we end up with 1 over 7 times 1/2, which is 1 over 14. Point values for this, you're going to get a generous 2 points for h prime of x. So this should have been an easy derivative to take. The reality, though, is if you just put 1 over f of x, you just got a 0 on this entire part. You have to make sure you apply the chain rule, and I would recommend that you apply the chain rule to every function, because you get down to the point where you're taking the derivative of x, which is just 1, and so it doesn't change the function. So just be careful. Make sure you apply the chain rule whenever you need to. And then you're going to get 1 point for your final answer of 1 over 14. So that should have been an easy 3 points to get. For part D, it says evaluate the integral from -2 to 3 of f prime of g of x times g prime of x dx. Now this, at first glance, looks a little bit ugly, but if you just look at it, you can see that you have the derivative of the inside hanging out here. And so this is really the results of taking the derivative of a composition of functions. So we should be able to see very easily that the antiderivative of this is just going to be f prime of g of x. You can check your work by taking the derivative of that, and that's exactly what you would get here. If you don't see that, you can try U-substitution, and that's what I did here. I said let u equal g of x, because g of x is inside, and then I took the derivative of u in respect to x, so I got du dx equals g prime of x. Remember, our goal is to get dx by itself, so we divide by g prime of x on both sides, and then you multiply by dx. And then we have to reevaluate your bounds. Remember, I keep hounding you guys on this, that if you have du at the end, and that's our goal when we're doing U-substitution, then everything in here must be in terms of u, and the limits must be in terms of u. If this says du, and you are left with from -2 to 3, you're doing something wrong, because -2 to 3 are x values. You need u values. So we're going to figure out our new upper limit by plugging in 3 into our u function. So we're going to say u equals g of 3, and then up here in the chart we've got g of 3, which is 1, so we can state that. And then our lower bound is going to be plugging in -2 to our u function, so we end up with u equals g of -2, and then g of -2 is going to be -1. And so we can say we have the integral from -1 to 1, because those are our u bounds, and now we're going to do some substitution here. We got f prime of u, g of x is u, and then we're going to keep that g prime of x there momentarily, and then dx we solve for, we got 1 over g prime of x du, so we're going to substitute that in. And then we notice in this integral expression that our g primes are going to cancel out, so we can simplify this by saying the integral from -1 to 1 of f prime of u du, and then we can evaluate this really easily. What is the antiderivative of f prime of u? Well, that's just f of u, evaluated from -1 to 1, and then we plug in our upper bound and our lower bound, and then subtract. So f of 1 is just 2, and f of -1 is 8, so 2 minus 8 is -6. So points for this, you're going to get 2 points for the antiderivative. So if you used U-substitution and you got f of u evaluated from -1 to 1, that would be your 2 points. If you did not use U-substitution and you just said the antiderivative is f of g of x, that would also be 2 points. And then you're going to get 1 point for your final answer of -6. So again, every FRQ is worth 9 points. You don't have to, and you shouldn't be grading yourself on this because we did this together. But now it's your turn. So you're going to do your problem. Let's see here. We did 2014 number 5 just now. Careful here. We're going to go out of order. So pay attention to this. You guys are going to be doing 2017 number 6 for your practice problem. And again, you can do this on your own. You can do it with a partner. You can communicate. Just don't try and look up answers or anything like that. Just do it with integrity. Set a timer for 10 minutes only, and whatever you get done in 10 minutes is how you want to grade yourself. Okay, we want to try and put ourselves on a time crunch so we get used to the pace of the AP exam. So again, set your timer for 10 minutes, do what you can, and then come back and watch the video on how to do this problem. Again, number 6 on 2017. I'll see you again later.